All right, I want to take a look at another example here, both to graph this thing and then to look at eliminating the parameter. A couple different ways you can do it, and then some issues related to that. So first of all, I want to draw the graph, but I want to draw the graph in a different way. I don't want to just plot points. Well, I mean, I guess I do plot points, but I plot points in a way of that rather than making a table, I'm going to make two graphs. That is, I'm going to do x versus t in my first graph, and y versus t, whoops, on my second graph. T is the independent variable. Okay, so as if I just look at this first equation and say, you know, what does the graph of that look like? X equals 1 plus e to the t. Well, e to the t by itself without the 1 would be this graph that goes up like that. Actually, I'm going to do this. This would be e to the t without the 1, right? It intercepts right there at 1. But then if I add 1 to it, see if I can do this, it just shifts it up 1. So it actually passes through the y-axis at 2. Okay? And the horizontal asymptote here is at positive 1. Right? Now the e to the 2t is going to pass through the y-axis there at 1. So this was t as the input, x as the output. Now I have t as the input and y as the output. And I'm trying to line them up so that I could say, here's for the same value of t, here and here. First one gives me the x value, the second one gives me the y value. So this is just e to the 2t. It's a similar shape. It stays flatter to the x-axis here to start with, and then it goes up faster than that one does. So this goes through 0, 1. This now goes through 0, 2 because it's been shifted up. But this is a faster growing exponential function than that one is. Okay. So what I see here is this graph is telling me what's happening in the x direction. If I was standing in front of a class, I would walk back and forth and say, notice that my head, or I hold a pencil out in front of me and say, as I'm standing here walking back and forth, the pencil that I'm holding here in my hand is not changing its elevation, it's just changing where it is left and right. Or I could stand still and I could move my hand up and down and move that pencil up and down without moving left or right at all. Or I could do both. I could use my feet to move sideways and my hand to just move up and down, and in that way I could draw different graphs. And that's the way I see drawing these parametric graphs. That this graph right here, the x versus t, is going to tell me what my feet do. Right? This is the x direction. This graph here is going to tell me what my hand should do. The y graph is the up and down one. Okay? So my feet only pay attention to this. My hands only pay attention to this. So, for instance, on this one, I look at this and say, what do my feet need to do? My feet, for t equals minus infinity for a long time here, my x coordinate is just a little bit bigger than 1. So here's 1. All right. The y coordinate is just a little bit bigger than 0. So I'm hanging around close to this point. The y coordinate is getting bigger. And in fact, by the time t gets to 0, the y coordinate has made it up to 1. At the same time, that x coordinate makes it up to 2. So I do make it up to this point here. But I kind of take my time getting there. And I notice that the y coordinate stays fairly small compared to the x until I get to this point. Then the y coordinate is getting big much faster than the x coordinate is getting big. So my hand is moving up faster than my feet are moving sideways. So if they were going at the same rate, I'd be just drawing a line here. But since the y coordinate is getting bigger faster now, I should be sort of bending more upwards. I'm moving up more than I'm moving over. Okay. So the graph looks something like that. Okay. So now I want to eliminate the parameter. Oh, sorry, a couple things. One is I notice that x never gets less than 1. I'm never over here on this side, right? And y never is negative, so I'm always above the x-axis. Right? What does this graph really look like? Right? Well, if I eliminate the parameter, I might be able to see some things. So I'm going to rewrite this down here. Actually, what I'm going to do is I'm just going to grab this and pull it down here now, and work down here. Okay, so to eliminate the parameter, I'm going to do this by taking this first equation and solving for t. So I've got x minus 1 equals e to the t, and then I take the natural log of both sides, and I get t is the natural log of x minus 1. Right? Then I can take that t and plug it into here and end up with y equals e to the 2 times the natural log of x minus 1, which the parameter has been eliminated, but certainly there's a simpler way of writing this. And that is to bring the 2 in here. So this is e to the natural log of x minus 1 squared. And then the e to the natural log cancel each other out, and I just end up with y equals x minus 1 squared. I look at this and say, hey, that's just a parabola that's been moved over 1. This is actually a parabola, y equals x squared, but it's been moved over 1. The x minus 1 shifts it 1 to the right. However, this equation, the graph of this equation, is the whole parabola left side and right side. But yet my parametric equations only described the right-hand side. So I want to take this and say, well, yes, but I'm going to restrict x to being bigger than 1, because that's what happened up here. For all the different values of t, x was always bigger than 1. In fact, not even equal to 1, because e to the t was never equal to 0. Okay. So when I eliminate the parameter, sometimes I have to say, this is the equation of the graph, but there's restrictions, right? Because of the nature of the functions involved up here, there's restrictions on the variables down here. Okay. Now, I'm going to take that set of parametric equations and eliminate the parameter in a different way, just to show you that sometimes there's a little less obvious, but sometimes easier things to do. The trick here is to notice that e to the 2t can be rewritten as e to the t quantity squared. Right? Usually you do it this way. If you have something raised to a power, you multiply the two exponents. Right? So e to the 2t. So what I'm going to do is I'm going to take this one right here. Rather than solving for t, I'm just going to solve for e to the t. E to the t is x minus 1. Then I can substitute that in directly for e to the t. So I have y equals, the stuff in parentheses is e to the t. I'm going to replace that by x minus 1, and then that's squared. Right? And I find myself back in this situation here very quickly. Right? Again, there is a restriction that x has got to be greater than 1. If you can see these sorts of things where you don't have to solve exactly for t, but maybe some bigger thing with t in it, and substitute that into the other equation, if you can recognize that, it makes your calculations a little bit easier to do. Still not wrong to do it the way we did it up there. So there's a second example of eliminating the parameter.